Okay, here we go. Absolute value. Absolute value is needed whenever you have an even root and the reduced power over root is odd. The only time you have absolute value that's needed. For example, I'm taking the square root of x to the 10. The root is 2, meaning it's even, correct? If I write this as power over root, that gives me x to the 5th. Because 10 divided by 5 is, or 10 divided by 2 is 5, correct? Which means now 5 is odd, so therefore I have to have absolute value bars around it.
Just to make sure.
Why do we have to do that? Because I don't know what x is. X could be positive or x could be negative.
I thought it was the even one.
The even root
Oh.
with a reduced power being odd, you have to add the absolute value bar. Okay? Now, listen. If x is positive, a 2 times a 2 times a 2 is a positive 8. Can I take the square root of a positive 8?
Yes.
I can simplify it, right? It's not going to give me an imaginary number, correct? But let's go ahead and make that a negative number. Negative 2 times negative 2 is positive 4 times negative 2 gives me
-8.
negative 8. Can I take the square root of a negative 8?
No.
Not without putting it in the imaginary number system. So by taking the absolute value of that x, which is negative, it turns it into what?
Positive.
A positive value, and then it allows me to take the square root of it. Does that make sense? So the whole point of the absolute value bars is whenever the power is odd, it allows it to stay positive. So I can take the even root of it.
Okay. But would we need the absolute value bars if that was a 6 instead of a 5?
If this was x to the 6, you would not need them because what is it? Negative times a negative times negative times negative times negative times negative.
The only way it's
Positive.
negative is if it's negative.
If you're going to have a positive outcome, then you don't need any absolute value bars. But because this could be negative, because it's odd,
So you're saying that this number can't be odd?
if I have an even number of
An
negatives,
even number can be
if I have an even number of negatives, the outcome is always positive. If I have an odd number of negatives, the outcome is always negative. Which is why the odd exponent gets the absolute value.
You need absolute value bars if you're like.
Only on the back side of last night's worksheet material.
Well, I know, but like, for example, on 24, it wasn't like the normal square.
I'm going to show you here. Okay, look at number 26. This is not off of last night's worksheet. Instead, this is out of your book work. I wanted to have more problems that were fresh out the book. Even or odd?
Even.
Root. The root is even. The root is 2, which means it's even. Which means I have a possible absolute value. ABS, absolute value. I have possible. Well, how do I know if I'm going to have absolute value? I have to calculate the problem, right? I'm not going to know until I reduce my power over roots. So I have the square root of 16 times x to the power over root. My power is 2, my root is 2. So what's the square root of 16?
4.
And what is 2 divided by 2?
1.
1. So since it's 1, is 1 even or is 1 odd? 1 is going to be odd, which means I have to have absolute value bars over the x.
just around the x.
Just around the x. Because 4 is positive. Can 4 be negative if the number is 4? Clearly not. I either have $4 or I owe $4. If it says positive 4, then I have $4. Did we get that? Check out 27. Is this possible to have absolute values?
No,
Why no?
because the root is an odd number.
My root is a 3, which means it's odd, which means there is no ABS. You simply calculate the problem.
Times the odd roots.
Because can I take the cube, the 5th, the 7th root of a negative number? Absolutely. Because negative 2 times negative 2 times negative 2 is negative 8, which means I can take the cube root of negative 8. Okay? I can get a negative outcome. But I cannot get a negative outcome when I have an even root. Never possible. I can get a negative outcome with an odd root. That's legit. Okay? I'm not going to do this problem. The whole point of this today is to make sure that when you're using absolute value, when you're not. 28.
It's possible.
It's possible because what's my root?
4.
My root is a 4, which means it's a possible ABS. What's ABS?
Absolute value.
Absolute value. It's a possible ABS. So how do I know for sure if I have them? I gotta do the problem. So my power is 20 divided by my root 4. My power is 28 divided by my root 4. What is 20 divided by 4? That's y to the 5th, x to the 5th. What is 28 divided by 4?
7.
Y to the 7th. So now, look at your powers. My powers are going to be what?
5 and 7.
5 and 7. Are they even or odd?
Odd.
5 is odd, 7 is odd. Since they're both odd, it requires absolute value on both of them. So, when do I need absolute value bars?
When your root is
When your
possible,
root is even
and your
reduced powers are odd.
Why would you need it though? Because if they're both odd, they would both be
Because
up.
I don't know for sure what x is. X could be positive or x could be negative. I've not assigned a value to it. I have not assigned a value to y. It could be anything.
Since they're both negative, you wouldn't need it.
You're right, because I'm multiplying together, but you don't know what x is and you don't know what y is.
No.
Y could represent the national debt, which clearly is negative. Just like. Are we good on
Only a
that?
couple trillion.
Yeah.
Are we good on that?
We can keep
I'm going to go over tonight's. What you got to do tonight, I'm going to do a lot of homework problems tonight, and then tomorrow I'll go over it. Okay, here we go. If you are given the nth root of a times the nth root of b, that is the same thing as saying the nth root of a times b. Translation, they're divorced, you can marry them. If they're married, you can divorce them. Make sense? You can pull them apart. Whatever makes your life easier when calculating the problem. If it's easier to yank them apart, then yank them apart. If it's easier to keep them together, then keep them together. Okay? Now, an index is another name for a root. So if I say what is the index of this problem, you're going to say, well, what's index? That means the root. Does that make sense? So in this example right here, what is the index of 4? Of the fourth root, sorry. 4. Clearly. What is the index of the fifth root of 5? 5. What is the index of this? 2. 2. Do we all understand that?
So when it's not marked, it's always 2.
When it's not marked and there's nothing in that nice little check mark, it's understood to be a 2.
Because it's a square root.
Because it's the square root. Kind of like saying 1x. You don't need the 1 in front of the x.
How do you think, like, 4 is what check mark on there? How do you think
The fourth root, the fifth root, the 10th root.
I'm just write that.
Combine radicals. How do you combine radicals? Well, the only way you can combine radicals is if the indexes are the same. If the indexes are not the same, you may not marry them. The indexes are not the same, you may not marry them. On vacation today?
Right down there.
Okay. The blue. Why can I not marry blue? The index of the first one is 3, and the index of the second one 2. Is it 2? So guess what? That's done. The red. I can marry those because my indexes are exactly the same, which then would make that, what is 6 times 2?
Third root.
The third root of 12, or the cube root. Okay?
The one before, like, where you,
Fourth root.
So I never understood why 3
Fourth
is
root of 40.
Same thing. Lovely. Same thing. Okay. This is number 11. You got a mouth. Use any other mouth.
Wait, I have a question. Why is 3 cubed?
Y is 2 squared.
Why is it
Why
called
is
that?
It's the reflection off the ocean.
There you go.
Why is
the
it
first
first
cube
cube
dead
and
inside squared, first cube dead inside the cube.
But
But number
a
11.
cube should be 6.
Sure.
Square should be
In your mind, it should. Why should be it be? Now, number 11.
6 sides.
The cube root of 4 times the cube root of 16. Are they the same?
Gosh.
Yes. My indexes are the same, so therefore what can I do?
Cube
Marry
root of
them.
64.
So I have 4 times 16. Now, clearly Scott doesn't mind doing mathematics, numerical mathematics, multiplication. For those of you who suck at your multiplication tables and have not memorized them still, you are going to suck at this. Okay? You are not to grab a calculator. That's not what we're doing. You have a calculator. It's called your brain. You've already learned this stuff. It's called apply it. So with that said, we are going to break this down. I'm going to teach you 2 methods. The first method is for those people who hate their multiplication tables. For those of you who are good at your multiplication tables, which I can say there's many people in this class. Factors of 16. How do I break that down? I drop down the 4, and then this is going to give me 4 times 4 because that's what 16 is. You see that? How many 4s do I have inside there?
3.
3. So I have 3 4s in there. I can write it as 4 cubed. What happens to your power and your root?
Wow.
They cancel out, and my answer is going to be 4. No thought really required except for breaking down to 16, correct? No calculator needed to grab. Okay? However, I have people that don't mind doing the multiplication tables, and they're going to say, well, 4 times 16 is clearly 64. And I'm going to say to you, what number multiplied by itself 3 times gives you 64? And the answer to that is going to be 4 cubed, which then power and root cancel out. I'm just showing you my work today.
I understand.
Clearly, I know you're going to go from here to here. I know. Well, I'm listening.
Just finish.
Listen.
I don't understand why it's 4 and not just cube root 64.
Because 4 times 4 times 4 is 64.
Wow. Would you give us a 4th power? 1 for 4?
What is with you in the 4th power? Do you have a fetish with the number 4?
Yeah, because like 2 squares, 630. No way you can say 2. That's a shortcut there. 2 and 4. Well, that's 2 and 4.
Focus, please. No. What do you notice here?
Negative. But it doesn't
Okay,
matter.
beyond that.
It doesn't matter.
They have the same
They have
negative.
the same index. They have the same roots. We're going to marry them. Negative 12 times negative 18 gives me a positive. And my little freakazoids that know their multiplication tables, I'm very proud of you, which is 216. That is awesome. Then you're sitting here and you're saying, well, that number multiplied by itself 3 times 216. Well, I'm going to go with, it's probably the next one here, which is 6 times 6 times 6, which is 216. Now, that is the true answer. However, half of this class, 3/4 of the class, is not going to get it like that. Not in a lifetime are they going to get it like that. So, we're going to put this over here on the side, and we're going to do it the way most of the people are going to do it. So this is going to be 12 times 18. Why is that 12 times 18? Negative times negative is positive. Nobody likes to overthink things, so what is 12? How can I break down 12 in perfect squares? 3 times 4. And this is going to be 9 times 2. Well, what do I know about 4?
It's a perfect square.
It's a perfect square, which is what?
2.
3 times 2 times 2. What's 9? 3 times 3. How many 3s do I have in there?
3,
How many 2s do I have in there?
3, yeah.
So what I have here is 3 cubed times 2 cubed.
You can cross out.
They cross out. That becomes a 3. That becomes a 2.
6.
And 3 times 2 is 6. That is how 3/4 of you in this class are going to do that problem, because you clearly are not going to grab the calculator, or you're not going to know multiplication either.
That's for 6 cubes now. 1 through 5.
I get you. He says he wants to memorize perfect cube form. Make it easy. Okay, number 19. What's going on with 19?
You're on sync. The cube, the square root and the cube root on sync. And,
Okay, well my index is a 2,
Yeah.
which is my square root. Okay? And now I have the cube going on
Have
there.
enough good values. Because 2 is not.
Tristan just said we have to have absolute value possibly. Well, why do we possibly have to have absolute value? Because my root is what?
Okay. And your.
My root is 2, which means I possibly have ABS. Okay, so let's just wait on that. That's a good thing. You're very proud of you. Now I need to find factors of 20 that are what? Perfect what? Y squared. Because my index is 2, so 4 times 5 works. Now, is my power 3 divisible by my index 2? No, it is not. So we are going to, in our head, break this down. I want a number smaller than 3 that is divisible by 2. 2 is my very first one I'm going to have there. So I'm going to have x squared times x. Why is that x squared times x? Because I have to have a grand total of 3 of those inside there, because that's what I had originally, correct? So now I'm going to go from left to right, and I'm going to simply break this down. So what's the square root of 4? Can I do anything with the square root of 5? What's the square root of x squared? And can I do anything with the square root of x? No. So I have 2x on the outside, and what's left on the inside? 5x. Now, Tristan said we may have absolute value. Now, how do I determine if I need absolute value? I look at the lovely little exponent on the x that's outside of the front of the radical. And it's a 1. And since 1 is odd, what do I have to add? I have to add the absolute value just around the x on the outside of the radical. Nothing happens underneath the radical. Box it in, and that's your answer.
You have to put extra first, usually like 2, maybe a 4.
No, 2 absolute value bars.
Like the 2, so we have the absolute value bar to x inside. I don't have to do that.
2 absolute value x times the square root of 5x. Because 3 is not divisible by 2. And 3 is not divisible by 2. Like all last night's homework, everything was divisible by 3. So I got a whole number every time. Tonight's homework, you are not going to have things divisible. So you have to break it down so the parts are divisible, and then have something left over underneath. 24. How do I do this?
Okay. 200.
Stay after school.
Okay, you got the.
How do I break down 200? 20 times 10. Well, I could do 20 by 10, but here's the thing. I'm looking for factors of 200 that are perfect what? Squares. So that means I want the biggest perfect square that I can find.
25 and 5.
So wouldn't it be really good to divide it by the lowest possible number first?
25 and
So
5.
what's the lowest possible factor of 200? 2. So what's 200 divided by 2? 100. Is 100 a perfect square?
Yeah.
How
Here's
about
the
that?
perfect square.
2 is not a perfect square.
No, it's not. I lied.
2 times 100. Why? Because 100 is a perfect square. 8 to the 6 is 6 divisible by my index 2. Yes, but alone. It's 7 divisible by my index of 2. No, so I need to think of a smaller number than 7 divisible by
B to the
2.
6 times B.
So that's going to be b to the 6 times b. Why is that b to the 6 times b?
You have to have a total of 7.
I need a total of 7 b's underneath that radical. Good job, guys. Now, what is the square root of 2? I can't do it. What's the square root of 100? What's the square root of a to the 6? A to the 3rd. 6 divided by 2 is 3. Very good. What about b to the 6th?
B to the 3rd.
B to the 3rd. What about b to the 1st? Nothing. It hangs out. So I'm left with 10a cubed b cubed times the square root of 2b. Now, am I done? Am I done?
Absolute value, you don't need
Do
to.
I need absolute value?
Yeah.
Yes, it's
No.
possible because it is even.
Even and you got odd exponents.
Possible ABS, and look at my exponents. My exponents are 3, which means they're odd, so I need to add my bars around my variables together, and then I'm done.
I don't like this.
I understand. It's not easy stuff.
You added at the end.
Patience, grasshopper.
Patience.
Copy it down. Okay. Are my indexes the same?
Yes.
Yes, so what can I do? Miriam, I'm going to marry the jump on the outside, and I'm going to marry the jump on the inside. So what is a negative times 2? Times the cube root of 2 times 15. How many total x's? 7 x's. How many total y's? Now, what do I need to do with that 30?
Break it down.
How do I break it down? What's the question I need to ask myself?
Largest perfect square.
Is it a perfect square?
No.
What am I looking for?
You.
What am I looking for? Perfect cubes, right? So, are there any factors of 30 that are perfect cubes? So what are my factors of 30? 10 and 3, 10 and 2 and 5. So what you're telling me is the prime factorization of 30 is 2 times 3 times 5. Is there anything in there written down 3 times?
I don't understand how you're getting on with
30 is 2 times 15. 15 is 3 times 5. Remember the old factor tree fact today? Which means 30 is 2 times 3 times 5. Are there any numbers in there that are perfect cubes?
No.
Absolutely not. Which means I can't do a darn thing with that 30, can I? It is just ugly and it's just meant to stay there. Can I break down x to the 7th into what? I am going to be looking for a number smaller than 7 divisible by 3. So what is a number smaller than 7 divisible by 3? X to the 6 times x. How about y cubed? That stays as y cubed. So now what? Can I take the cube root of 30?
No.
No, we discussed that. Can I take the cube root of x to the 6th? X to the 2nd. Can I take the cube root of x?
No.
No, can I take the cube root of y cubed?
Yeah, well,
So what's my answer?
2x squared.
Negative 2x squared y of 30x, which is left over. Do I need absolute value?
No, because it is an odd root.
No, because it is an odd root. And since it's an odd root, there's never a possibility for absolute value. My index is 3. Since my index is 3, it's off the table. It's not possible.
Even if it's on the outside.
Doesn't matter. 41. It's ugly. I'll give you that. What do I do?
You gotta break down 48.
Are my indexes the same?
Yes.
So what should I do? Miriam. So that's the cube root of 48x cubed y squared over 6x to the fourth y.
Oh.
Is 48 divisible by 6? Yes, it is. What is 48 divided by 6? How many x's are up top? How many x's are on the bottom? So how many x's are left? Where are they? There's one x left on the bottom. How many y's do I? Well, what's 48 divided by 6?
You got one y on the top.
I have y squared on the top and y on the bottom, leaving with one y on top. Okay. Divorce them. I know. It ain't nice. Now, I have a problem. What is the cube root of 8? 2. Can I take the cube root of y? No. So I'm going to put 2 times the cube root of y over. Can I take the cube root of x? No. Here is where things get jacked up for y'all. There's this lovely little rule that says you cannot have a radical in the denominator. So what you have to do is rationalize the denominator. Rationalizing the denominator means you are eliminating all radical expressions by multiplying by whatever you need to eliminate that radical. Well, the only way you can eliminate a radical is if you have however many the index is inside of it. So what's my index denominator? 3. So how many x's do I have in there currently? 1. How many do I need total to eliminate radical? 3. So how many more do I need? 2. Whatever you multiply by on the bottom, you multiply by on the top. I need 2 more x's on the bottom to give me a total of 3 x's. So I multiply by what I needed, which is 2. The cube root of x squared or the cube root of x squared. I vary the 2 radical expressions on top to give me 2 times the cube root of x squared y, and I vary the bottom to give me the cube root of x cubed. Yep. What is the cube root of x cubed? It's an x. So I have 2 times the cube root of this x squared y all over x, and that's done. We're going to do one more. Turn that round upside down. Can I simplify the cube root of x? Can I simplify the cube root of 2?
Need 2 more 2s.
I need 2 more 2's on the bottom. Why do I need 2 more 2's on the bottom? I can't have a radical at the bottom, and right now it's the cube root of 2. And there's only 1 down there, so to get rid of that I need 2 more. So I'm going to multiply by the cube root of 2 squared over the cube root of 2 squared. What is 2 squared on the top?
4x.
So I have the cube root of 4x all over the cube root of 2 cubed. Why is it 2 cubed down there?
It was 2, you multiplied by 2
Because I have a total of 3 2's down there. And what is the cube root of x of 2 cubed?
2.
So at the top it's the cube root of 4x all over 2, and that's it.
They all be like that.
Tonight's homework is chapter 6-2, practice A, 9 through 49 odd. Clearly I have done several problems for you already, and I made you do them all in your notes, didn't I? Why did I make you do that? Because I know for a fact that many of you are still clueless, so you need to go home and you need to do this again on paper for one assignment. Then, if you get clueless, you need to go back and figure out what we did. It'll benefit you nothing if you sit there and copy tonight's notes on tonight's homework. I would redo them. If you choose not to, that's your problem. We are done.